Good afternoon, guys. This is a really quick video about a topic called thermal decomposition, which is relevant in a lot of places. It comes up in C4 types of reactions. I'm also going to demonstrate something called the law of conservation of mass, which comes up in C3. So it's a bit of information today, but it's quite a quick little video. So what I'm going to do also solves that problem as well about if you've got your birthday coming up and you're planning having a party with just you because it's lockdown, you might not want to blow up your own balloons. So we're going to use chemistry to solve that problem for you. So what have we got? First of all, I'm going to show you our reaction and then we'll apply it to our balloon situation. So we have a chemical here called, I'll show it to you, it's not very clearly written, copper carbonate, which is copper, carbon and oxygen all stuck together in one compound, so copper carbonate. When you heat this, it goes through a reaction called thermal decomposition. If we break that apart, thermal, heat, decomposition, break apart. So thermal decomposition means break apart with heat. So here's one I've already prepared. So literally just a boiling tube with some copper carbonate in the bottom. What I'm going to do is quickly weigh that, and it weighs 32.26 grams. You'll see why I'm doing that in a second. I'm then going to get my flame, put it on a roaring flame. I'm just going to heat this over the button. Might take a few seconds. So that will be thermally decomposing. What we do is quite a lot of chemicals. If you ever see a chemical with that really bright green colour, that's normally telling you that there is some copper in there, because copper ions have that lovely green colour. So it's starting to go just now. You might have to see, I'll break up the camera just a second, but it is quite quickly changing colour. So it's bubbling a little bit. So if I bring up the camera, you might never see my lovely green powder. Still a bit of green in there, but it's now mostly black. They just turned into something else. So I'm also now going to just let that cool quickly, place that back on my scales, hopefully without burning my fingers, and the mass is now 32.14 grams. So I have lost mass. Somewhere, somehow, a chemical must have come off of this in order to make it lighter. So we'll talk about that in a second, and I'll go to my board and we'll just talk about what happened in this reaction. But before we do that, while I'm still in front of the flame, we will therefore gather a little bit of evidence and solve our problem with the balloon at the same time. So, same situation. Here is my powder. This time I've got my balloon that I am too lazy to inflate myself, sitting on top. So, much the same. Put it in the flame. Okay, it'll probably take 10 seconds or so. Probably how it's put it in the hottest bit of the flame, isn't it? And if you start to see what is happening, of course, my green copper carbonate is becoming the black chemical, wherever that chemical is, and my balloon is starting to inflate. So clearly, I must be making a product which is a gas. And if I carried on doing this, obviously it would inflate that balloon. The lazy chemistry way. So, thermal decomposition. We have broken down that copper carbonate into something different, in fact two different things. So in thermal decomposition, you normally start with one chemical and turn it into two or more. So one thing breaks down into simpler things. Pop over to my board and we'll explain what's happened in this chemical reaction. Okay, back at my board. So one thing I should have said, with the so the first experiment I did without the balloon on top, obviously we lost some mass. Second one with the balloon on, had I then reweighed it and weighed it at the beginning, you would have found the mass was the same. So obviously in the first one I was making a gas that I wasn't collecting, so it looked like I was losing mass. Wasn't really. It's in chemistry, the law of conservation of mass says you cannot lose mass. Whatever mass you start with is what you finish with. It's just I was making a gas which was escaping, so what I was weighing was less. Second one, obviously, because I trapped the gas, it would have weighed the same. So what have I made? Start with copper carbonate. There's the problem with copper carbonate. One copper atom, one carbon, 3 oxygen. I'm not reacting it with anything, I'm just breaking into simpler things. Now we know we made a gas because something inflated the balloon, which should give me a massive clue really. If I look at this, what's the obvious gas I could get if I break that down? And in my brain I'm thinking, well, I know a chemical called CO2, carbon dioxide. So the gas we were making was CO2. Had I wanted to prove that, if I bubbled that gas through lime water, the test for CO2 is it will turn lime water cloudy, so I could have done that test. I can now apply my rules of chemistry. If I start with those atoms, I've got to finish with those atoms. I've used up the carbon, I've used it to my oxygen, still got oxygen left, and I've got a copper left. Copper and oxygen is, of course, copper oxide. That was the black powder that I was creating. So, there is the full equation for the thermal decomposition of copper carbonate. And the key things to remember: thermal decomposition, you heat it, you break it down into something smaller. If it's a carbonate, what you make is the oxide and CO2. So if I'd used calcium carbonate, I'd have made calcium oxide and carbon dioxide. Cheers guys, see you soon.